a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. Throughout this next chapter on percents, always keep your mind dwelling on one central idea, and it will help keep much of your work simple in concept. And that idea is that there are many ways of writing the same number value. Just 3 examples here. 6/8 when reduced is the number 3/4, which when you perform the division, 3 divided by 4 is the decimal 0.75. And they all look different, but they all are the same number. That's the purpose of these equal signs. This chapter merely explores yet another way of saying a fraction or a decimal. Decimals represent a system which limits us to a set of special denominators, that is, strictly powers of 10. By so doing, we were able to write those special fractions without the denominators, and to treat decimal numbers with whole numbers as though they were whole numbers in our basic operations of addition, subtraction, multiplication, and division. Now, percent notation simply concentrates upon the use of one of those decimal denominators, 100. Your future work with percents can be kept simple if you always hold the following few facts in mind. The word per means symbolically the same as our fraction bar. Cent means 100. So read this, per cent. Actually read it that way, as though you're learning a foreign language. Also remember that the word of means times. So once again, per is that mark right there. Cent is that mark right there. Of frequently means times. Remember those 2 or 3 facts, and you'll find that the topic of percents becomes quite simple. A statement like 5%, which in script could be just as well have been written this way. And it's well to equate this symbol with this and not with mathematics. This is simply a written symbol to shorthand this word. And that means, when translated to mathematics, 5, per, cent, 5%, 5%. And if you get in the habit of treating this as though you're just writing from one language to another language in which you write things differently, again, it's going to make our business of percents a great deal simpler. Because any time you can say hundredth or per hundred, you are saying percent. Let's note an example. If I take the common fraction 3/4 and multiply the bottom by and the top by 25, it would become the equivalent fraction 75/100, or 75 per 100. Now, instead of writing the per 100 in normal denominator form, we're simply choosing to replace this per 100 written this way by this mark right here, percent. Percent per hundredth, percent per hundredth. 75 per hundred, 75 75%. So again, the word per hundred or hundredth and percent are two ways of saying and writing the same thing. This lesson is to merely get you used to that basic idea. As an example, if you have this statement that 37 out of 100 people have had a flu shot. Now let's express that ratio first. 37 out of 100 have had a flu shot. Now when they say to express this as a percent, we simply want to, as a matter of notation, to replace those marks by that mark. This means percent per cent. Just that simple. Another one. We have the expression 8 parts to 50 parts. 8 to 50. And for whatever the reason, we wish to express this ratio or fraction as a percent. But to do that, the denominator must be 100. So if we were to, in this case, multiply top and bottom by 2, the denominator becomes 100th. And as soon as we have per 100, we can replace that per 100 with percent, because the two mean the same thing. By now you're beginning to realize that that fraction bar means a great many things. Let's look at some examples. It means per. We could say 3 per 5 of something has happened. It also means out of. 3 out of 5 people voted. Sometimes it will mean in, ratio of, and divided by. And before we're through, it will mean a lot more. And if the denominator is not just any old denominator, but 100, which in this case I could get by multiplying top and bottom by 20, and getting the equivalent fraction, 60 100ths, then this fraction bar still means per, and a 100th with its Latin name means hundredth. So 60, instead of writing per hundredth this way, we will write per hundredth that way and call it percent. Now sometimes certain symbols or certain statements are so simple, the simplicity itself can fool you a bit. 35 out of 35. 35 out of 35, which is another way of saying, of course, all of. Okay, but that, of course, reduces to 1 over 1 or just 1, but I can't express it as a percent until that denominator is 100. So if I multiply top and bottom by 100, I now have 100 per hundredth, and this per hundredth becomes percent. So it might help with a few future problems if you remember at this moment that 100% and all of mean exactly the same thing. If I were to say 100% of this group voted, we mean all of this group voted. Now for a fraction like this is not quite so obvious. What I can multiply the bottom by 7 to get it to be 100 to say percent. But notice if we state the question mathematically, 3/7 is. Okay, equal is another way of saying is. What number per hundredth? Or if you will, 3/7 is how many hundredths? If I knew how many hundredths, then I would know what its percent is, because percent means how many hundredths. But this is a rate proportion. And remember, to solve rate proportion, top times bottom, set equal to bottom times top. And to solve this equation, the second step is to divide both sides by the multiplier of the unknown. And so my x is 300/7 100ths. A rather messy way of saying it. So usually we'll take the 300/7 and divide it out, and we'd get 42 6/7. So using this more complicated way of writing it, 3/7 is 42 6/7%, 42 6/7. But as soon as we have the per hundredth, we have percent. So 3/7 and the number 42 6/7% are precisely the same number, just written differently. Let's do one last example. A family monthly income is $1,200. $450 of it is spent on house payments. What fraction of the income is spent on the house payment? Express that as a percent. Now let's write this fractional part as a ratio first. $450 out of $1,200 is the fraction that I spend on rent. Now if I want it as a percent, I'm asking 450 per 1,200 is how many per cent per 100. Now solve this proportion. Top times bottom is 450 times 100 equals bottom times top, which is 1,200 times x. Divide both sides by the multiplier of the unknown. And of course down here it would have canceled out. And this is the top of a fraction whose denominator is 100. So this is my answer. This is my percent. So we can simplify this either with a calculator or by hand, but either case we'd get 37.5 is my x. My per 100 was what started the whole thing. So this per 100 can be replaced by that mark right there. So this family spends 37.5% on rent. The whole point of all of this now, remember, is simply that this mark and the word percent is just another way of saying per 100. And that's all there is to percent. However, it's the basis for comparison of almost all rates of changes in business, that we'll see in the following lessons. As we go on into this chapter, it also would be very helpful if you could keep at the back of your mind the answer to the question, why did we, especially in the business world, go to percents in the first place? Remembering that percent means per 100. Why? Why did we restrict ourselves to a single denominator? In particular, 100. Well, consider this question from our fraction days. Which of these two fractions is the largest? Now that's rather difficult. And the thing that's really complicating the decision is the denominator itself. After all, if we had written these two fractions so that they would have the same denominator, in this case, the denominator 245, and I'll leave it for you to check if you wish that these two will have a least common multiple 245. Then adjusting the numerator so that these two fractions are equivalent to these two respectively, we would have, instead of this form, the same numbers in this form. And in this form, it can be seen cleanly that this is the larger fractions. So to compare fractions easily, it was convenient to have the same denominators. But if we're always going around having to get common denominators, you'll agree from that section in our chapter on fractions that our arithmetic life is made somewhat complicated. So we make an agreement. Let's agree from now on that we will always have the same denominator when we wish to compare things by fractions. So then we have to ask, of all the possible numbers there are for denominators, which is possibly the easiest? And it doesn't take too much thinking to realize that 100 is the easiest. But then if we make the agreement, we always will have 100th, almost always. Then we quit writing it this way and simply invent a shortcut way of saying that I have that common denominator of 100th. Now, of course, we don't always do this. So when we do use that commonly agreed upon common denominator of 100, we will indicate that we have entered into that agreement by using that symbol right there. Consider this situation. Two neighbors, the Adams, who take home $1,800 a month, pay $450 in rent. The Williams, who take home $1,500 a month, pay $420 a rent. Now, if we look at these two rents, it looks as though the Adams actually pay less in rent, in fact, $30 a month less. And in absolute sense, that's true. This is less money going out than what the Adams have to pay for rent. But let's look at it this way. The Adams pay $450 out of $1,800 per month they have available. And the Williams pay $420 out of not $1,800 but less money. So we could ask a question, who pays the least rent relative to what they're making in terms of paycheck? Well, that's rather difficult to answer just by looking at these two fractions. But if we can agree to go into that common denominator, where we'll let B stand for the fraction on the Williams and A for the Adams. In fact, it's well in algebra to pick variables to really help you. So why B for Williams? Why not W for Williams, A for Adams? Now, if we were to solve these proportions, and let's review that very quickly. Recall from our last chapter on proportions, to solve for this, we take the product of the two numbers that lay on the diagonal without the variable. So 450 times 100 is simply 450, two more zeros for the times 100. Then we divide by the number on the diagonal with the letter or the variable, reduce it, divide this out, and we would have that the A is 25 per 100. But in this chapter, we're agreeing that rather than writing it that way, we're going to write it this way. So to say that Adams pays 25% of their salary in rent is the same thing as saying that they pay $25 per every $100 that they make. Now let's do the same thing for the Williams. Again, we'll multiply those two, which is 420 times 100, divide by 1,500. So 420 divided by 15 is 28. So we could say that the Williams pay $28 per every 100. And again, rather than saying per 100, we say per cent, just as a substitute symbol. So relative to their income, it turns out that the Williams are paying more out of their income, relatively speaking, in rent than the Adams are. And this is a very convenient way of comparing how people are doing relative to a standard base. Because sometimes just looking at numbers by themselves, it can be misleading, because what you really pay for rent really to a large extent depends upon how much you make, doesn't it? And so percents give us that ability to compare things very quickly and make decisions like this one. Here's another question like that. Town X has a population of 15,250, of which 780 are retired. On the other hand, of Town Y's 42,380 people, 1,200 are retired. Now, in terms of absolute numbers, Town Y has more people retired than Town X. But our concern is this: relative to their populations, which town has the greatest ratio of retirements? So if we were to take from Town X and form a ratio of the retirement to the population, it'd be convenient if we can get this to that common ratio that we're agreeing upon at the start of this chapter, that is per 100. So if we solve this proportion, which I will very quickly, and we'll round the x to the nearest tenth, we would get that 5.1 roughly out of every 100 of Town X's people are retired. And of course, we're suggesting at the start of this chapter that we will replace this per 100 by the simpler symbol percent. Doing the same thing for Town Y, it has 1,200 retired people out of 42,380. Now we'd like to know, what is that per 100? So we can compare it more easily with Town X. So again, solving this proportion, we would get for Y 2.8 per 100. And again, instead of saying per 100, we say 2.8 now per cent, which means the same thing. So now let's compare the two towns with this new understanding of that word percent. And things take on a slightly different appearance. We're saying that in Town X, 5.7%, which is the same thing as saying 5.1 per 100 of its people are retired. Whereas in Town Y, only 2.8 per 100 are retired. So relative to the population, Town Y has fewer retirements, even though in actual number there are more. But that's because the town, of course, is so much bigger than that. So you see, it is convenient when you wish to compare things, and of course in the business world, government world, scientific and health world, we are always comparing things. Then it is awful convenient to have a common denominator, and of all the denominators, 100 is the one we've chosen to use. And so we denote that by this symbol of this chapter, percent. If you live in a state or city that has property tax, you can see that how much you pay in property tax depends upon the value of the house. But if you were to form a ratio, the taxes paid per property evaluation, and to change this into a percent. Now, to change to a percent, remember percent means per 100, means how many per 100. And then we're simply going to replace this per 100 by this new per 100 symbol. So solving this proportion, and by now I hope that you're very fast at doing this on the calculator. 1,500 times 100 divided by 75,000, and we get 2. So we're paying, in effect, 2% of our on-property tax. Now, this value will change for all of your neighbors because their property evaluation will be different, house per house. But if you construct all the ratios of their taxes per house evaluation, they should all come to the same 2% if they are being taxed equitably. So you see, this percent gives us an awful convenient way of comparing things when the thing we're comparing it is changing from family to family or business to business. So percent is a tool for comparison in business and all kinds of very informal statistical reporting. This chapter wants you to get used to that and comfortable. But in order to be comfortable, we would recommend that you should first be very, very comfortable at solving proportions. If you are not, you might want to pause in this lesson and go back to previous lessons and do some more review problems. So from this lesson, simply remember the word percent, whether written as a word or by this symbol, means per cent or 100. If you just keep that at the back of your minds, this will prove to be a remarkably easy chapter. And if on top of this you're quite comfortable and accurate at solving proportions. This is your math host, Bob Fennell. We'll see you at the next lesson.